Hello, everybody. Good morning, afternoon, evening, wherever you happen to be. Welcome to the SmartNICs, the Future or Folly panel at SC21. Thanks for joining us this Friday. I have 5 panelists with me today. My name is Ryan Grant, and I'll be your moderator. And today we have Duncan Roth from HPE, Gordon Brebner from Xilinx, Steve Poole from Lanel, Roxana Ishida from ARM, and Rich Graham from NVIDIA with us today to talk to us about SmartNICs. So just a bit of background on me. I don't have an opinion, obviously. I'm a moderator. I will occasionally play devil's advocate if there's too much agreement amongst the panelists. But I've had some experience with SmartNICs over the past as well. You may have seen me listed as DOE staff on this event. I've actually moved to Queen's University since then. And we had a SmartNICs BOF from earlier this week where we asked the question in the poll, what do you think SmartNICs in HPC are? What are the future? And we can see that the vast majority of people who were attending that BOF thought that it's very promising technology that hasn't quite proven itself yet. So a very timely panel discussion for us. But I should note that no one thought it was a passing fad. Everybody thought that it's either the future or a promising technology with a small group coming in under interesting technology, but the impact will be modest. So to give you the general feeling for the overall community feelings for SmartNICs. And with that, I'll introduce our first panelist. Duncan, would you please take it away?
Hi, I'm Duncan Roth. These days, I'm a senior DT at HPE. I joined HPE with their acquisition of Cray. It's quite a nice role. It's as close to a pure research role as you can get, in that I don't have anyone reporting to me, and I get a lot of control over my time. So I get to work on a range of our future networking products. So planning for what we're going to be doing in the next few years, and this includes a variety of different SmartNIC projects. So NICs with some interesting fixed function offload, and NICs with some programmable offload. Little bit of background. Before I joined HPE, I worked at Cray for about 10 years. And together with Greg Farnes and Pete Ongaro, I established the Slingshot program at Cray. So this is the interconnect for the US exascale systems and a bunch of HPE systems. So before that, I was a founder of Quadrix. So firstly, is it the future or is it folly? There's always been NIC function that benefited from offload, and some of that's always been fixed function, things that we understood that aren't really going to change in the lifetime of a product, and some of it has benefited from programmability. Certainly, the first programmable NICs that I worked on were Elan NICs back in the sort of 2000s. So, as to its role, we're focused on NICs for supercomputing applications, and the area and power that some function uses and the amount of effort that we put into it needs to be proportionate to the added value. So there are certainly some commands and messages and packets that do benefit from the attention of a core, but not so many. But there are some that certainly do. It's good that there aren't so many, because new designs have to process multiple 64-byte packets per core, per cycle, and if a large proportion of those need the attention of a core, then that's lots of cores and probably quite a lot of added latency if you're having to process each one. Another thing that's important about the supercomputing use cases is they tend to be multi-node per application rather than multi-application per node. So we have to look at, which are use cases that are relevant to supercomputing and which of them are relevant to enterprise computing or commercial HPC. And you end up in a very different place. Another observation we did some work with the SPIN team over the last few years, looking at processing of messages and packets, even in embedded CPUs. They're really not very good at it. And the overheads of doing quite simple things are high. So you need to get a lot of value out of this. So for me, the interesting thing is programming models. And so a couple of models that I think are interesting for HPC. Firstly, triggered operations, which is all geared towards packet manipulation, performing operations on completion, initiating new communications. It's been around for a long time. We started in this direction at Quadrix. It's part of Portals and libfabric these days. It's implemented in our NICs. But also the spin model that was developed by initially people at Sandia and ETH. And so there's some interesting papers in that area from ETH. So let's hope there's some interesting questions from you all. Thanks.
Thanks, Duncan. That's great. Next up, we have Gordon. Gordon, please take it away.
Okay, I remember to unmute myself. So hello, everyone. I'm Gordon Retner. I work for Xilinx, which is the FPGA field programmable gate array company, which is very shortly we expect going to be part of AMD, a larger conglomerate. So I'm in the CTO office at Xilinx, which is the kind of further out research arm. My particular role is leading research into networking using FPGAs. And I've been at Xilinx since 2002, and originally it was very much FPGAs on line cards for telecom systems. And that's where we're looking at packet processing. But the rise of the SmartNIC in my universe has been over the last 6 years or so, looking at the FPGA being a central component on a SmartNIC to do kind of processing close to the network, and ultimately that led to. After a long gestation and things along the road, as Xilinx product launched earlier this year. So SmartNIC, that's our term of the day. What I coined a few years ago was SmartNAC before that was thwarted by marketing, who said I had to have NIC in the title. And what we were looking for was more network attached compute. So it wasn't just putting smartness on the NIC path, between the network interface and a CPU, but actually having a bit more oomph, smartness, if you like, but thinking about actually doing things like data compression, perhaps, or data filtering on the way through. So, kind of when we talk about SmartNIC, SmartNAC is in my mind, and as people will know, other terms are now unleashing themselves, like DPU and IPU, etc. So, on another panel, we had a debate about what is a SmartNIC. So it can mean a lot of different things to different people, which we should bear in mind in this discussion. My own HPC connection is kind of very ancient history, which would interconnect for parallel computing, which I did with Les Valiant way back in the early 1980s in Edinburgh. And that was I was doing big area networking, but also sort of closer area networking. And today, my main connection is working with particularly the Department of Energy's ESNet people on the wide area network, connecting supercomputer centers and into places like CERN in Europe as well. So a much greater scale of HPC networking for connecting together supercomputers in the more coarse grain. So some of my general interests are in what I'll call converged hardware acceleration, with FPGAs, obviously, because I work for Xilinx, where you're accelerating your computation and storage, which is a big thing for us in Xilinx, and also the networking. Before I joined Xilinx, I was a long-term inmate at the Department of Computer Science in Edinburgh, latterly the School of Informatics. So the advantage of not going first is I can say Duncan's points were all very well made, and I agree with all of them. So I don't have any heated debate, unfortunately, with that. One of our briefs was, and our SmartNICs, the future of HPC. I think I'd want to stress that are an important part of the future of HPC. So SmartNICs, including FPGAs in my case, are one piece, but I'm not ruling out, CPUs and GPUs. I mean, they're essential to the mix. But so I see SmartNICs are one of the big 5 components, let's say. As hinted on the previous slide, we could go from, as Duncan was talking about, kind of low latency supercomputer interconnect kind of scale, and granularity with things are more tightly coupled, to what's my current interest is, distributed edge science, where you have big scientific instruments, you put some NIC-related processing before they hit the network with their big data, and you're doing that in real time. So for me, and the story of the NIC is really processing big data in motion, and then we have the big compute and the big storage, which are doing what they're good at. And the SmartNIC can really do inline data processing, not just packet processing, and also help to offload functions from both the operating system itself. Move the hypervisor into the SmartNIC as one of the kind of discussions, and offloading applications where it makes sense to do things in the NIC closer to the data. Echoing Duncan's point, is what is the software model for all of this? It's relatively easy to construct the technology, but then how do you actually use it and integrate it with applications without losing all the performance or performance power benefits? So that's my basic story on the SmartNIC, and I again look forward to the discussion.
Okay, thank you very much, Gordon. Okay, next up we have Steve Poole from Lanel. Steve, please.
Hi. Yep. Hi. I guess my title is sort of Chief Architect, Senior Scientist, although at Lanel they call me a Scientist 6, which I think means I can say I'm anything and yet nothing. I have no management responsibilities, thank goodness. My management chain thinks that's a very positive thing. I try to guide and direct, and that's about it. With NICs, I use, specify, and develop. I guess I've been working in the networking arena since before Hippie. So anyone here that actually remembers Hippie knows that there were things actually before Hippie. Hippie had, of course, a lot of capabilities, but to program the NIC was actually more difficult than using FPGAs, because you got to go back and then recast whatever it was in the firmware that you wanted. Other than that, it was pretty much a rock stupid interface from the programming point of view, but it was fast. And then I went to GSN, which was an SGI thing, which was sort of not much brighter. And then I was on the DARPA program for HPCS, and that's when the torrent was developed. That was an exceptionally interesting network. It was programmable-ish, but it certainly allowed us to do some of the things that we needed to do from within our application space. My background in HPC is forever. So I guess I started when I worked for Steve Chen at Cray. I was on his special programs team, and that was right before they invented DIRT. And we did our own network back then for both for the system as well as for the interconnect and the external. I've done a bunch of work with the long haul network teams. We did that in Dallas at SC, where Lyndon from NRL and some of the others, we literally shipped a live stream across the country, which was kind of interesting. So it's a different kind of networking. And what do I wish for? World peace and end of COVID. Next slide, please. Future or folly? Well, I think I agree, at least in part, generally speaking, with everything that everyone else has said. I'm not necessarily, I only look at the SmartNICs that we're using. So by the way, we test all of them. So the religion involved is it's got to solve a problem for me. If that happens to be an FPGA system, awesome. We have FPGA programmers. We will do what we need to do. The point there is we have to be able to build a bit stream ourselves, or at least modify the bit stream that we're given from the vendor. We use it already for data compression. We use it for analytics, and we're using it for some other things in the future. And as I say, if they're smart and programmable, they'll be useful. If they're smart and really difficult to program, then that becomes a little more challenging for us. And my point is, as a developer, from both an application point of view and from a system point of view, I find it difficult to tolerate someone handing me a library that says, I think I know what you need to do, and I know more about what your applications are, which in many cases may be true, but I'm not going to accept that as an answer. I have to be able to put in what it is that I want as far as algorithms or offload kernels. If they're not very bright and fast, yet programmable, we'll probably evaluate them just to see how they fit in our system. And in our case, a lot of our NICs or SmartNICs or whatever you want to call them are going into a secure environment. So we have to worry a lot about not only being able to program it for what it is that we do, we always have to worry about the security. The other thing is they cannot cost twice the price of a normal NIC. Because when they're that expensive, it makes it very difficult to justify from a financial point of view, me filling up 10,000 of these things that now are a lot more expensive than I could have gotten with a fast high-speed interconnect. Next, please. So we're doing something about it. Lionel and some other folks have formed this open source consortium where we're actually trying to generate an open API for SmartNICs and eventually for smart storage. It's already underway. Ryan's part of it. There are a lot of people involved. And we decided that we couldn't be programming 26 different languages. We needed to have something that I can give the apps team and say, here, run this program. It'll tell you whether you should offload or not, because there are many times when offloading is a complete and total disaster because it runs slower than it did if you had no net connected. Next, please. We just announced I announced it this week. We actually have our first software release. There's the magical GitHub site, and this is we're developing benchmarks which use already existing benchmarks, but we're hooking them up to SmartNICs. And so we've started that. We're putting the structure in so that anybody can run this, and all these benchmarks will be available, and you can compare it against the standard versus something with a SmartNIC. Sometime we'll tell you whether you should offload or not. Next slide, please. And this is just announced is sort of a public but not too public announcement of our next machine. We will be purchasing a machine in 23. It's called Venado, named after a mountain in New Mexico. Where else? This is some of the content of it. It's a stepping stone for us because we're going to use this machine to actually analyze SmartNICs, DPUs, whatever you want to call them, smart storage, as well as standard interconnects. It's going to be 100 petaflops modulo some number, and we're hoping to have, if not maybe SmartNICs, at least relatively bright NICs inside of it. I think that's my last slide.
Thanks, Steve. That's great. All right. Up next, we have Roxana. Please take it away, Roxana.
Hi, thank you. So yeah, I'm Roxana Ishida, and basically I'm a data center systems architect for ARM's infrastructure line of business. So what that actually means is I basically look at kind of all upcoming technology across the data center and the HPC kind of product lines, and I work across very wide range of technology types, from things like SmartNICs, where this kind of comes in, to system architecture and what's going to go into our processors, etc. And as I said, SmartNICs are one such technology, and I'm looking primarily for kind of use cases and the problems they can solve, and how can we use them more cleverly in a way. And in terms of HPC, I've actually been part of the ARM team within ARM Research that's actually helped bring ARM into HPC. So yay or sorry, depending how you feel about it. And I've spent nearly a decade basically doing this, working in research on everything from performance optimization methodologies to novel system architecture, software ecosystems, and a lot more. And I thought I'll put some kind of personal stances on SmartNICs, just to kind of, let's say, insightful, hopefully good comments. So I think they're good for offload a kind of very kind of certain small tasks, right? Things like near data processing and data manipulation functions in general, things like, compression, decompression, etc. System and auxiliary compute as well, for a lot of the kind of systems functions, checkpoint restore, why not? And I think they can also, by kind of offloading some of those small functions that don't necessarily require a lot of compute, you can potentially get more predictable performance on the main processors, which actually can be a nice thing sometimes. And again, lowering unpredictable due to I/O. And from the other perspective is, I think they're going to be very interesting, obviously integrated with high performance storage as part of basically with computational storage devices. When combined with those, I think they can make a very interesting offering as well. And kind of in general, I believe the heterogeneity at all levels is here to stay. To my kind of co-panelist points, I think programmability is going to be key, and how and when we use them are the main open questions. And obviously I welcome debates on this. Yeah, that's me.
Thank you very much, Roxana. So next up is going to be Rich Graham, and he's on site, so he's going to take over sharing off of his laptop. I'll just take the opportunity while Rich is getting set up to say to everybody, please post your questions on Slido. If you're in the room, you can ask questions, and Rich will try to relay those questions to us as well. We've already got a good set of questions lined up, and as what I can see from the current attendance, this is one of the best attended panels at SC that I've been involved with or have attended so far. So thank you, everybody. Great to have good attendance on a Friday panel. So Rich, you're all set up. Please take it away.
Okay, so my name is Rich Graham. I work for NVIDIA. I joined NVIDIA via the Mellanox acquisition. So I've been there for about 10 years, focusing on HPC technology as it relates to distributed applications, to parallel applications. Prior to that, I spent 15 years at Oak Ridge National Laboratory, and before that at Los Alamos. And a lot of the work that I've done has been in the area of communication libraries. So I was one of the starters, one of the people that initiated OpenMPI, for example, and was chairman of the MPI forum for about 5 years. Including MPI3. So that's my background. So in terms of network SmartNICs, I figured the easiest way to share, to sort of show my view and our view as to what SmartNICs can be used for, from a slide that shows at a very high level a platform direction that we've announced recently for the platforms within NVIDIA. So if you look at this figure, there are two different figures of how systems are being built. One on the left that indicates how systems are built, most often built today, and those that on the right is the direction that we're moving into in terms of products. So all this is based around, in terms the hardware to support this is based around a SmartNIC family called the Bluefield family of NICs. Today, the current Bluefield NIC is our second generation NIC, Bluefield 2. And with the NDR generation of technology, we're having a second. Our third NIC will come out creatively named Bluefield 3, and this is in 2022. And so a few key things to draw from this figure. I'm not going to go into all the details by any means, but if you notice, one of the big things that happens today, in terms of management. So a lot of the focus here is on host management. A lot of the activities that happen in terms of management happen on the host, where computing is done. So of course you have your application running. You have communication libraries that run there that manage communication progress often, even with offloading capabilities on the HCAs. There still is a fairly decent portion of just application level progress that needs to happen there. Storage management happens there. As well as all the issues around security, system security and isolation. And so the intent, one of the directions that we're are working on these days is moving the management capabilities to the DPU to free up the host to be able to use most of the cycles for compute and reduce the amount of cycles that are necessary to spend on other management issues. So this is probably one of the most important things that's being downloaded, and this is aimed not just at HPC centers, but very much at data centers too, is all the security aspects of management. And also management of storage. So work that's being done on the host today to write files to storage and the like is being moved down to the Bluefield. Communication libraries are being, like MPI and SHMEM, portions that make sense to migrate to the Bluefield NIC are definitely being moved there these days. And there's also the opportunity, of course, for the application to use cycles there. And that particular area is actually an active area of investigation, as the people on the panel are aware of, in terms of what actually makes sense from an application perspective to move down to the SmartNICs. So clearly things that involve data motion over the network are things to consider. That's why a communication library, for example, is a very natural thing to move to the Bluefield. But there are other aspects of applications that are being explored in various places around the world in terms of trying to figure out what other capabilities make sense to move to the NIC. So that's briefly, that's all I have to say. So back to you, Ryan.
Thanks, Rich. I will share a slide just for a second here to get back to our first question that we had from the audience, because it relates to this first intro slide. So the question that we got from the audience was, how would each of the panelists vote on the survey from this intro? Looking at the current generation offerings, not the distant future. So why don't we start off with, why don't we go in the same order we did the slides? How about we start with Duncan?
Well, I think most of the interesting SmartNIC function's been evolving over a long period of time. It's been given new names, but programmable offloads and fixed function offloads that can be used have been there for a good few years and they'll continue to develop. So I'd say they were both part of the past and the future.
Okay, thanks. Gordon, your thoughts?
Well, I'm very positive about it. I think they're definitely part of the future, but part of me would tend towards the promising technology that hasn't proven itself yet in certain HPC contexts. I think, for mainstream SmartNICs, connecting servers to networks, that's pretty bread and butter nowadays. But, fully integrating things with HPC and, working out the balance between, what's offloaded to the NIC and how the whole thing's programmed, there's a lot of kind of research questions to be handled. So I believe it's the future, but there's a lot of work to be done.
Okay, thanks, Gordon. How about you, Steve? I think I know where you might come down on this.
Yeah, so I don't disagree with my colleagues. I will echo what both of them said. SmartNICs, or something that would be considered a SmartNIC, have probably been around for 25 years. So they're not brand new, that's for sure. They were not as clever as they used to. They've had IQ boosts as of late. But I certainly believe we have tried and broken many of the capabilities of the current SmartNICs because of speed, functionality, et cetera, but I certainly believe that they're part of the future and am betting heavily that that is in fact the case.
Okay, thanks, Steve. Roxana, your thoughts?
Yeah, I'm one leg into the future and one leg into the promising technology that hasn't proven itself yet. I agree again with my colleagues here. And just to add, I think we're gonna, as the hardware evolves, right, I think more and more use cases will become more apparent in a way. And also we start seeing the gaps that we already have today. So I think this will be a quick evolution, over the next kind of give or take 3 to 5 years, or even probably less than that. But I agree that they're definitely here to stay. But yeah, that's it for me.
Great, thanks. Rich, your thoughts?
Yeah, so I generally agree with what's been said so far. The slight modification is they are present today, right? There is already some use for it today, more in the data center and not so much in the HPC. And so I believe they're already starting today. There's still a lot of work to do to bring them to the level they need to be, both in terms of hardware functionality as well as in terms of supporting infrastructure for HPC applications to actually improve there. But I think that's area that's, at least for us, is very active within NVIDIA. And that's it.
Thanks, Rich. With deference to the audience is asking great questions and really filling up the Slido. I have a question that relates into this, though, so if you permit me one question, I will then get out of the way and let the audience ask the rest of them. And that was really that, given that we saw SmartNICs in the past, right? They've been around for a really long time. There was a bit of an explosion of them in the late 1990s and 2000s. But SmartNICs are kind of different now than they were then. What makes the panelists thoughts on why they didn't catch on and become the super hot thing in the 90s and 2000s, where they are seeming to catch on now? What's changed between that last 2 decades, when the last explosion of new SmartNIC designs came out, that you think might make them more successful in terms of adding compute capability in the network this time around? Anybody want to go first?
Sure, I'll go first. So I built a programmable NIC in the early 2000s, and precisely 3 people programmed it. And 2 of those worked for Quadrix. We did MPI and collective offload, which was done within Quadrix. And the third person was Jarek Niploko, people perhaps may remember, who programmed ARM-CI multi-dimensional puts. And it was really hard to program, and you ended up with something that wasn't portable. It performed well, but it was only available on that particular system. So you had difficulty of programming, no portability, and good performance only on one very specific platform. So and it died a death because it wasn't essential. So what have we got to do better this time? We've got to enable people who are building runtime libraries to use it and to be able to port their result between different platforms. And we've got to keep it away from actual application programmers need to work at a higher level where they say what they want, not how to do it. And then people can target SmartNIC application. They can target characteristics of different NICs, and in a way that might achieve a broader spread of applicability.
I'll make a comment here. This is Rich. So I think one of the things that's different this time than before is the early NICs. They were really sort of a boutique type of thing. There were very few people, as Duncan said, that had the skill or took the time to learn how to program them. I think one of the things that's changing now is, first of all, the SmartNICs on themselves have a very large demand in data centers. Maybe for reasons that aren't necessarily related to HPC directly. And so there's a base demand there to build this technology in the first place. And I think, and the second point that Duncan made was about programmability, or the point he made about programmability. One of the things that, for example, we do with our NICs is they're programmable with your standard GCC tool chain. They run Linux on the NICs, and so you don't have to be an expert to be able to try something out. So at the get-go, it gives an opportunity for a lot more people to explore ideas So I think the combination of those two, and I'm sure there'll be other things that'll come along that will need to be addressed here, things like performance and the like. So.
Yeah. I think I chime in with Rich there. If you look at that time frame, like 1989, 1990, maybe that was too early in terms of NICs, SmartNICs becoming mainstream. Like 5 years later, when CPU speeds and networking speeds, and then like 10 gig kind of Ethernet networking was coming along, the rise of the SmartNIC with offload functions, you could really date back maybe to the early aughties, 2005 kind of thing. So in terms of being more mainstream than just very custom kind of HPC NICs, the mainstream NIC technology wasn't really justified then. CPUs were still fast enough. So if they'd come along 5 years later, modulo programming problems, my guess is there might have been more takeoff.
So I guess I'll, chime in. So having been one of those demented individuals that actually programmed some of the early NICs, one of the problems we had was not only was it NIC specific in an architecture, it was a system specific in most cases, a system specific NIC, i.e. the NICs themselves were not portable to anything that I needed to use them on. So once I wrote some code or changed a driver so that I could actually use it, if the minute we changed a vendor, everything just went in the dumpster. And then 2 years worth of head banging and self-flagellation with a whip to get through all the work just went in the dumpster, and that was very difficult. The other thing is that FPGAs and FPGA tool chains have evolved over the past 15 or 20 years. They used to be like banging rocks together, and the FPGA itself had very limited programming space, very limited number of CLBs. You could only do, you had to write, well, it was a good thing you had to write extremely tight code, but it also said the level of functionality that you could actually put in any of these was exceptionally limited. And by the time you get one place where you think you're almost done, you just ran out of room, or you couldn't place and route anything at greater than 10 megahertz, which is not a super fast process. So I guess I would say that even the more difficult NICs to program, which would be the FPGA systems, have evolved a lot, much better tool chains. I don't have to spend $250,000 for a tool chain from any vendor. Makes no difference who it is. I can get some of it free and at least test things out. So there's been a lot of evolution since the early 2000s.
I like to kind of turn the question a little bit and look more in the future as well, right? Perhaps why they become more critical going forward relative to in the past is also the fact that CPU performance, while it's going up every year, and we're doing our hardest to do that, there is only so much you can squeeze, year on year. And I think heterogeneity and the ability to distribute basically compute and not move the insanely massive amounts of data that we already have today, I think is also going to become critical going forward. So yeah.
Yeah, at the risk of dating myself, I remember Steve programming the old tool chains with FPGAs and hacking firmware to flash it with a SmartNIC. And yeah, probably programming firmware is not the place most people want to be. Right? So I can see there's a massive difference.
Not for very long. It's a very scary place.
I know. I've bricked my fair share of former SmartNICs from the early noughties. Okay, great. So I'm going to start asking, there's a ton of questions in Slido. Please vote for your top questions up. I'm going to start with the most popular upvoted questions and ask them of the panel. So if you want to see your question answered, please vote for them. So our number one question is, do any commercial SmartNIC offerings have advantageous NIC to CPU connectivity? Putting PCIe in the middle isn't very interesting. You might as well go to the main CPU.
Rich looks as though he's about to explode. So I would vote that we nominate Rich to answer that one first.
So how do I say something without saying something? So first of all, I'll say that PCI is improving over time, right? PCI Gen 4 is a lot better than 3. PCI Gen 5 is also much better than 4. And so that in itself already is a vast improvement over what was there before. Of course, there are other opportunities to do better. But the latencies that are there are getting so small anyhow. I guess that's really the only comment I can make without saying anything else. Thanks, Steve.
Always. I mean, clearly, people are looking at using other interfaces, C6 had some traction, not much. CXL, maybe it can, we can get closer binding into the CPU. But you're right at the point of competition, if you like, between commodity and function here. So yes, people can do a nice integration into the ARM on-chip network, for example, but then that's where your product lives, and maybe it isn't so easy to integrate into, or maybe it's quite expensive to integrate into the major CPU vendors' on-chip networks. So you're at the point where the compromises start, and we see compromise all over the place as a result.
Yeah, maybe I could take that slightly different direction. So PCIe is kind of table stakes, for getting into servers. But then the interesting problem for me is, minimizing the amount of stuff you're moving over the PCIe. So if you can genuinely kind of offload things into the NIC at the network connection and then ship it out back to the network again, then often there's cases, the classic NIC model is, the NIC's just there to ship data from the network to the CPU and back again. But if you can actually offload processing into the NIC, then you can actually turn things around, collectives implementation, for example, without the CPU and hence PCIe being involved. So the interesting question is, how do you sort of minimize that traffic so that the application and the systems still work together?
Yeah, I definitely agree with that point, and I'll say that one of the means that we have at our disposal to use in terms of minimizing traffic, because of the sort of model that exists, at least in the NIC that we develop, we can actually on the NIC do network work on behalf of data that's actually host resident. And so the data itself doesn't actually have to move to the device itself, be processed, and then move on. But that's because of some of the hardware gather scatter capabilities that we have within our NIC. So these sort of things are certainly being taken into account, and people are seriously thinking about how to improve the ability to work between the host and the network at the same time while you're not giving up on security.
So there are a number of interface studies currently to make them generic enough, and I'm not talking about OpenSnappy, I'm talking about at the hardware level, because one of the systems that in the past, there have been things that have not, of course, used PCI Express, and I've never been a great fan of PCI Express. It's fairly well known. It does its thing, but its thing is not what I necessarily like. There have been instances where the NIC was exceptionally close to the CPU, and with the new design of chiplets coming out, I could easily foresee a capability of having a nice die shrink on something that looked like a SmartNIC setting tied directly either to a memory port or to the CPU subsystem itself, so that I can completely bypass what acts as a PCI Express interface. So I don't see that as being that far-fetched. In fact, I don't see it being far-fetched past 26.
Okay, thanks, Steve. Our attendance at this panel has gone up quite a bit in the last couple minutes, so I just want to mention to everybody online, thanks for joining the panel. Put your questions in Slido and upvote them, and I will make sure that the most popular questions get answered.
Can you give us a hint of how many?
Sure, it varies between the different live streams. We've got at least 60, 70 people online. It goes up and down. And then there's people in the room, of course.
27, I just counted.
27, okay. So we're touching close to 100 people, which is fantastic. Thank you, everybody, for attending. We really appreciate it. Okay, and I should also mention that for those of you who don't think that PCIe is interesting, there was a session with Debender Das Sharma, who's the head of PCI Gen 6. It's worth taking a look at it. PCI Gen 6 is significantly different than previous PCI generations. So I encourage you to go back and look at the recording from that session as well. Okay, any final comments, or I'll go on to the next question. All right, from Jeff Young from Georgia Tech. How quickly do we think we can standardize on a common API for data transfer, OpenSnappy or some other solution, with different CPU, GPU, and FPGA variants of SmartNICs? Do we want to take a stab at that one?
I can try to have a go at that one. I was going to say, coming up with a standard and kind of rallying sort of say everybody behind it and accepting, you know, let's just do, say, for example, you said OpenSnappy, just using that example from Jeff. I don't think that's the hard part. I think there will always be the traditional software thing of either not invented here, / I want to do that one thing in a slightly different way. And you will have alternatives springing all the time and an evolution of the standard. So how quickly can we do it? You know, I think once hardware becomes more mainstream, I would say it can be within a few years. It's possible. How quickly are people willing to accept one standard, for lack of a better word? That's well, I think there's an XKCD about that. I'll defer to my colleagues as well.
Yeah, I would expect that the capabilities would need to become the capabilities offered across the range of NICs need to have some commonality in them so that it makes sense to come up with some sort of interface. So I think right now things are very, very early in terms of, even though SmartNICs are not new, but for areas around HPC, when you think specifically about compute on the NIC and stuff like that, I think it'll take I expect it'll take quite a while for people to be willing to come close to a standard. I mean, obviously there are groups that are working together, like in the context of OpenSnappy, where there, what is it, half a dozen or more organizations working together on this, but that's still a relatively small number.
Yeah, the nice thing about standards is that they change. Or let's say they evolve, and hopefully at least the original design, the original concept behind OpenSnappy was to make it so that it could evolve, but not erratically. So adding new capabilities to OpenSnappy was a part of the original design, just like OpenSHMEM. OpenSHMEM took multiple instances of implementations of SHMEM and sort of tried to work with the entire community to make an API that has a cadence of release, and acceptance of new functions into OpenSHMEM is done by vote. We meet, and I would expect something like that to happen. At least I will push for it in OpenSnappy. We are not vendor specific. The original intent was no one vendor controls OpenSnappy, which is why we did that, because I've seen that in the past and it's been a disaster. So one of the things that we're looking for, Jeff, is we will hopefully release a 0.0.01 release of OpenSnappy in the first quarter of 22. So you attend the meetings, feel free to vote and make your opinion known. But I do expect OpenSnappy to evolve over the next couple of years so that we can, so Lanel has actually set up a test bed. We are testing out all of the SmartNICs that we can purchase, acquire, late at night or however we have to acquire them to put them in that test bed so that we can start testing them out in what we need for our applications and for our systems.
Yes, the goal of a single standard is hard to achieve. I'll point out that even though we think of MPI as the communication for HPC, it is not the only standard for communication, right? You've got OpenSHMEM, you've got tons of different solutions there too. So people are always doing their own thing in addition. I think the question is really, when does any one API potentially become the dominant one?
There's also the question of what's driving the market at the moment. So various different forms of SmartNIC, really infrastructure NICs in widespread use by the cloud service providers. Now they're the volume market for these components at the moment because they need to isolate you from me, and they want to sell their resources to both of us, so many of them are designing their own NICs, and people want to show them the benefit of using using their own product instead of continuing to make their own. So there's the volume is going, that's where the volume is at the moment, and other things are building fairly slowly. It strikes me that this is going to be an area where little NIC companies start up and innovate and burn very brightly and either get bought or explode. And it'll be some time before you get to a position where there's an established market for systems that run a particular software base that people will implement up to. We're kind of in the other phase at the moment where people are looking for new applications and they want to exploit some niche to, because that's the way their VC-funded company is going to, get bought by a bigger company. But
Thanks, Duncan. I think you're prescient or you're monitoring the Slido, because that very nicely leads into our next question, which is, what are the panel's thoughts on SmartNICs for secure multi-tenancy? Obviously, this is big in the cloud area, and as Duncan just mentioned, a big driver of SmartNICs. And HPC never gets what we want. We always have to use everybody else's toys, right? I mean, that's the way it's been forever, right?
Well, I'll say that was one of the big drivers for us getting in this market in the first place. The need for security and the need for storage management. So, yeah.
So this is back to the a comment earlier about what your applications look like. Many HPC applications today, you're allocating large numbers of nodes, and you have exclusive use of all those resources. And the NIC's role in this sort of future view of infrastructure is to provide real isolation at that level. Whereas in the sort of wider enterprise market, they really do want to sell the same resource to over and over and over again. So the NIC has to, the separation has to be down at the NIC level for that. It's a bit of a challenge getting, large scale applications running in the first place. Getting them running when you're having to share the resource with somebody else's application, share the physical resources with somebody else's applications makes it a lot harder. So once people get into that path, the next thing that they'll want is that, when my application and yours are sharing the same resources, that NIC's going to have to guarantee performance to both of them, or the platform as a whole will. And that's going to be hard to achieve.
So in our case, I'm not worried so much about known or assigned multi-tenancy, because as Duncan says, most of our applications in the area that we are concerned about consume the entire machine for, let's say, 6 months. to run one job. But I am concerned, and we are concerned about some of the capabilities of multi-tenancy as far as protection goes, because just in case someone decided to become a tenant of mine that I didn't invite them to become a tenant of mine, that is a concern, which leads directly into security questions, which is where we're looking at some of the multi-tenancy capabilities or restrictions to help us ensure that we don't have necessarily uninvited guests on systems that we use, because once you have the capability of a really clever NIC, if it's also very fast, you now have opened up an entire realm of mischief. And so we are concerned about that greatly.
Just to add actually to what Steven's saying, actually, with the advent of confidential compute, right, as soon as that actually gets adopted more and more into this in SmartNICs, that's going to be another, you basically, there is an opportunity to obtain much stricter hardware protections as well, in addition to all the software protections, of course, that come from, running Linux and everything else, and, containerizations and virtualization, etc., to ensure basically more secure multi-tenancy. And yeah, that's the other one.
And if you think OpenSnappy is interesting, or coming up with an API for some kind of programming interface, you should join the Confidential Computing Consortium when it's literally a planet-wide consortium, and trying to come up with a common one for that is just a joy to watch.
Grab the popcorn.
So as a sort of follow-on to this existing question, because we're getting a lot of questions about multi-tenancy, do you think that all of this multi-tenancy interest from cloud is a benefit or negative for HPC, or does it not matter? Do we not care as much?
I think you can choose to enable it if you want to, right? It depends on you. If you ever want to go in that space, you can basically choose to, hey, I want to run this with, say, confidential computing multi-tenancy or not. I think having the option is more important than not being able to in any shape or form. And it depends if you're trusting, certain threads versus others.
Yeah, and I'd say on top of that, the fact that there's a large demand from the data center means that there's a base economic incentive to build these sort of devices. And so if you want to use these sort of devices for things that are not just security, and the like, there's already a base infrastructure there that's being funded anyhow, so you don't have to invent that from scratch. So it makes it a much smaller increment to provide additional capabilities that are targeted perhaps at HPC, as opposed to having to invent the whole infrastructure aimed just at that one market.
Right, and to echo what Rich just said, I think I'm more than willing to let them get the bruises and do a lot of the funding, as Rich said, and then we can later on look at what the capabilities are and what the impacts might or might not be in a more dedicated environment. But having them do a lot of research and spend an enormous amount of money trying to make sure that all of this works and protects you at the levels at which you might want to be protected in an environment, I think it's an excellent thing. I'm not against it at all. And then if they come up with something that's extremely useful for HPC, I think we should adopt it, as long as it doesn't kill all the other performance.
That's a good point, Steve. So one of the other questions that we have that's quite popular is sort of, do we see that we have a smooth transition here potentially from what we have in HPC today, without having to throw away all of the stuff that we currently have for non-multi-tenant solutions like our shared file systems and in-band monitoring? Or do we want to sort of wait and take the gigantic leap when clouds figured out that multi-tenancy solution? Or do you see a more gradual evolution way that we could begin migrating there with HPC rather than just taking the plunge? Is this going to be a system-to-system change? Is this going to be a harsh generational change that just think we flip a switch and we have it? Or do you see this growing over time?
So I think if it's a harsh generational change, it probably won't succeed, right? I think there needs to be, some evolutionary path, so you don't have to. If you break everything, not very many people are going to try and make the move.
I think there are some HPC problems that are that are amenable to this type of processing, that make good candidates for showing people the benefits of a new way of doing things. And you can code them up in your favorite API and let people use them and change them and adapt them and things. Yeah. That'll get things going.
Yeah, I totally agree with you, Duncan. I mean, I think in HPC, some of the natural things to look at is for example, moving portions of your communication library that aren't necessarily uploaded to the NIC today to a place where you can program, where you can a lot easier offload them to another device to run asynchronously. The application doesn't have to see any change there, and so I believe that that's certainly one of the areas. Not wholesale. You have to be smart on how you do it, because there are costs moving management between the main host and a NIC. But I think that's one of the very early and relatively easy targets.
I think part of this is on the HPC community, oddly enough. I think the HPC community, and it's getting a little bit better, as I said in Monty Python, it's getting better. The HPC community, normally when someone says cloud, they recoil in horror and say, why should I talk to a bunch of dweebs? Because I'm sure they're not doing anything that's of any value or any intellectual challenge to HPC. We might actually want to reconsider that stance at least one or two times, because they are doing things that can be of longer term value to HPC. As I said earlier, they're doing an enormous amount of research. And there are, as Duncan said, quite a few people who have actually started slowly trying to quietly sneak things like this into the HPC infrastructure so that people don't know about it. And then all of a sudden when they say that was brilliant, if you're honest, then you say, I got that from a cloud study. And it's been integrated, like when containers first came out, everybody thought, God, what a POS, point of sale. And didn't want to have anything to do with it. Now, it's almost ubiquitous. I mean, especially in some of the offerings from HPE and some of the other vendors, containers and the like exist. By the way, containers are also exceptionally old, but it's a really good new old idea.
Yeah, and also the cloud doesn't necessarily mean temporal sharing of resources, right? So they're, yeah.
They certainly aim to be able to provide you with instances that have HPC-like function, and the major cloud service providers are all pushing in that direction. So they want to integrate that function into their broader environment. And as does my employer. That's definitely the way HPE's as a service infrastructure is going. The stuff that we're building to run their new model looks in many ways like cloud infrastructure. It's just you can have a supercomputer instance in it.
And to Duncan's point, I do think that adopting those things it will not be instantaneous. I'm sure that Duncan has a few scars on his knuckles from trying to implement some of the container services that they're doing. But eventually, if you keep banging your forehead, you either will pass out or you'll get something that works well. And I think we owe that, in some part to the cloud people who have been banging their heads for some time to do this. But I do think many of those things will have to be adopted into HPC.
Okay, thanks everybody. Let's change gears from multi-tenancy and cloud a little bit to get back to a traditional HPC topic, which is total power consumption of facilities. Adam asked, how powerful do you make NICs? Eventually you start cutting into your node's power budget. How do you strike a balance of those? Gordon, do you have any thoughts on this?
Yeah, well, this is something that's on our minds all of the time in doing SmartNIC, especially FPGA-based SmartNIC is to fit into the data center, in the mainstream use case, then there's pretty tight power budgets, and that's certainly one of the restrictions on just how ambitious you can be in terms of functions in the SmartNIC. So in my kind of a grand vision, all sorts of things would be offloaded into the SmartNIC from the CPU, but we have to be realistic in terms of networking functions and relatively light compute functions. So ultimately, I think Steve alluded to more integration, perhaps, of some NIC technology into CPU technology, using chiplets, etc. That's one kind of rescue strategy. But in the current setting, where we're doing kind of PCI cards, for SmartNICs, then there are quite well-defined power budgets. And that's definitely another limitation, to the kind of ambition of the offload. So, I think maybe with more evolution in HPC, we can get away from this kind of standard data center case, where things are very tight, to having bigger power budgets, in the HPC context, and then we can do more ambitious things. But at the moment, that is a kind of pretty severe restriction on how ambitious we are, in standard data centers.
I want to add to that and say it also depends on what functions you're trying to offload to them. At the moment, it's mostly, as we said so many times, data center and networking functions. As programmability increases and adoption increases and the compute function, there's a drive to accept more and more compute functions, irrespective of how we integrate. I think we'll also see a bigger demand to have more powerful compute. It's not that we can't do it, it's just, does it make sense to do it? And when does it make sense to do it? And that's the way I would think about it. That's the thing, right? If you put enough kind of goodness there, we have, for example, today, GPUs of PCIe that can take 300-400 watts. So we've got the budget if we want to have the budget, right? It's an accelerate, right? If SmartNICs do become like a GPU in terms of usefulness, right? Like how often, what's utilization? If you're spending 5% of the time doing something there, you're gonna give it up corny. If you spend 99% of the time doing something there and something big enough, then we'll add more more increases to capabilities.
I do think a kilowatt SmartNIC will be just a bit of a challenge for a lot of people to put inside of the system. It's just a guess on my part.
I'm sure Rich has got one plan, because that will just be 5% of the node budget soon.
Yeah, if you want to make it really smart, just put another node on, right? Or buy another GPU or something like that. I think it's the point that was made. It need to understand what makes sense to put there, and not. You don't really want to. If you're migrating all the compute resource to the SmartNIC, haven't you just made a new compute node? So, yeah. And
it's in many cases it is about the power, but it's less about the power than the money, because the amount of power, of course, is directly related to your budget for electricity. And if you have a 30 or a 40 megawatt system, and you increase that by 10%, you say, well, 10% is not that much, but that's a fair amount of money when it comes to the number of millions of dollars per year that you have to spend on electricity. So, to all my colleagues' comment, yes, I do understand it, and it would be of interest to see from some of the infrastructure people what they think their bounds are from an infrastructure and costing point of view. Rather than tell us we want you to come back with a different answer, I always say I don't do well with bring me another rock. I would like you to at least tell me what the rock sort of looks like.
And I'll make the other point, too, that the intent here is to improve system efficiency, right? Not to migrate capability from one place to the other place. So I think that's one of the things that really drives decisions. If you can do the same functionality without inventing anything new on the host, why move it to the NIC? So that I think that goes back to the use case scenario. So moving functionality from the host to the NIC, for example, makes a lot of sense, because you're freeing up your compute resource that has all sorts of capabilities that you don't need for management. Vector for resource management, for example. You're returning them to the application for use. And so the same thing on the NIC here. When we go to computation, looking at computations to make sense to do, you really want to look at, what sort of algorithms can I improve where the data has to go on the network anyhow. I don't want to move data from the host to the network just to do compute. You've just increased the latency of computation all of a sudden, right? So I think that's where these long-term or longer-term research questions come in terms of what really makes sense. What's a better way to distribute the work relative to what's done today? So I think
that also brings up the point of not keeping it at the end of a wire per se.
Yeah.
So I consider PCI Express the end of a wire. So when I have to move things across the end of a wire or a connection point, it's extremely expensive. So when I can bring some kind of network acceleration function much closer to either the processor or the memory subsystem itself, I now don't have to pay as much for the, to basically off to the NIC and back again, sort of a Frodo kind of thing.
Certainly, if I can do things that free up memory bandwidth in the CPU or the GPU, so that's available to people's applications, that brings a really high return because you pick your platform and you've locked into a particular memory bandwidth, and you can only go down from there as things take it away. So applications where the NIC can free up memory bandwidth for the free up main CPU or GPU memory bandwidth for the application. That's a really good candidate.
Mm-hmm. Yep.
Yeah, it's all about memory, right? I mean, memory is way slower than compute. Compute's cheap now. At what point do we get to the point where the SmartNIC becomes the host and the host becomes the SmartNIC? I mean, we can see these things merge eventually, right? I mean, I could see an architecture where you had a SmartNIC running Linux hooked up to a whole bunch of GPUs, and maybe that's sufficient for running your problems in your particular data center. Do we need CPUs? We
seem to have lost Duncan.
Yeah, I was just gonna also try to answer the question. I mean, SmartNICs on average, some of them definitely have CPUs in them, right? That's the thing. I think what you're really trying to, please, let me see if I get what you're actually trying to ask here. Do we need as high performance CPUs as we do to do some of those functions, or do we need higher efficiency CPUs, and that's good enough, as you said, right? The high efficiency CPUs, like, with GPUs attached. Is this kind of the way you're going along, or?
Sure, that's one of the ways you could do it, right? You could also split it with a big small core. There's lots of different architectural solutions that you could have, right? You could also just think about the NIC getting integrated into the CPU, and then there's no such thing as the NIC anymore, right? There's multiple different ways that you could see the architecture going with this.
And then there's CXL on top of that with different compute types, and just to add to the variety.
So I will say that integrating them all in one becomes an interesting challenge if you do it in 3D. I did that in 2001, and that was a rather interesting and challenging from every possible dimension, money, technology, because it was a design of a full 3D stacked system, which had the network, the memory, and all of the processing all on one 16 high, 2-inch by 2-inch wafer. And by the way, that's expensive. Don't try that. It will leave marks. But to your point, yes, the question is balance. Do I stuff effectively the NIC inside of a GPU, stick the NIC inside of a processing unit? Well, the NIC is already a processing unit. So yeah, and I think these things will evolve over time. And I do think that even though we could do all of them with it's just a matter of money. I do think the broader acceptance of those is going to be the challenge, because I don't think everyone will be willing to afford them. And I don't think necessarily the HPC community anymore is a large enough market space to drive a vendor, well, you can drive them out of business, but to drive a vendor to build those things, because it'll be a while before they're commodity. And we did lose Duncan, by the way.
Yeah, and I think another point too is in terms of integration. I think you really need to be careful when you if an integration is a solution, how you go about it, because you don't want to tie technologies that progress at different paces together in terms of when they can come out. Is network technology tends to in terms of generations move a little quicker in terms of life cycles than, for example, compute technology.
Right. To Gordon's comment early on was the fact that they may have been out a bit too soon and failed because they were out a little too early. All of us have seen technologies that came out, 5 or 10 years too soon, died, and then later on down the road, someone reinvented it again, and it was a miracle.
Yeah.
Well, in the late 90s and 2000s, CPU technologies were faster than networking technologies in terms of their releases, right?
Well, but
So
that's not necessarily generation to generation, right?
okay, if you consider TikTok a generation or not, I would agree with that.
Yeah.
Depends on how you consider what a generation is.
Yeah, that's right. Yeah.
Speaking, by the way, of kind of processor performance versus kind of NIC performance, I see a question around with to saturate kind of the high bandwidth networks with lots of cores, can a low powered ARM core with less cooling keep up at 400 gigabit a second? First of all, it doesn't have to be low power. We have got lots and lots. We've got multiple lines of processors. We've got we've got kind of HPC data center oriented process for high performance processors, and I can say yes, we definitely can. Keep up with 400 gigabit a second. Depends how it's integrated and how many you use, etc. But yeah, it's an easy one.
I think that's a good point, Roxana. Don't just think about SmartNICs as a NIC that somebody's added like cell phone level ARM cores to. When you hear ARM doesn't necessarily mean low power, low speed anymore in terms of ARM cores. There's some serious server grade ARM chips out there. So we have to be careful about how we talk about ARM cores anymore, whether we mean the low power stuff meant for mobile or the higher power stuff meant to be plugged into the main lines.
Yeah, there's this interesting little system that sits in Japan called Fugaku. And I think that sort of proved the point that ARM is certainly not strictly not for your mom's cell phone. It is still number one this year and is an interesting feat of engineering.
And I was going to say, even mobile phones, by the way, they use 3 types of, so you've seen the kind of the three types of processors in there as well, in big, little, even those can pack a punch. So, yeah, as you said, it's all about balance.
Yeah, I'm certain nobody will release a SmartNIC that's completely unbalanced that can't keep up with its line rate. I mean, that's a fairly obvious benchmark to meet.
Yeah, and if they do, they will terminate in whichever fashion you prefer the original designers of the NIC.
Yeah, that design team is not going to be popular. So moving on a little bit to a slightly different topic, one of our top questions that's remaining is, what are the interesting, and I'll broaden it just a little bit. There's questions specifically about interesting network protocol applications of SmartNICs that the panelists have seen, not compression, like rolling your own RDMA type stuff about adaptive routing. But I just want to broaden that question a little bit so that we can capture some of the interesting applications that are being used in SmartNICs as well. So if you have anything that relates to network protocol, we'll sort of prioritize that. But if you have any interesting applications of SmartNICs that are being used today, I'm certain the audience would love to hear about that too. Anybody have anything on the protocol side? I know, Gordon, you have tons of interesting stuff on the SmartNIC itself being used for security applications and whatnot.
Yeah. I mean, on the general protocol point, one of the utilities I'm very involved in is the P4 programming language for network processing, packet processing, and that's something. I'm sure it is built into our own SmartNICs. That's giving people the ability to do custom protocols, which would have been hard to do, especially on FPGAs previously. So you could actually implement custom protocols rather than just having your standard protocol stack, which isn't very interesting in terms of programmability, or in our case, using the FPGA. So we're certainly seeing use cases where people are using their custom protocols, e.g. on top of UDP, for example. There are more direct application-specific protocols that have their own application-specific protocols. So it's not just vanilla TCP with some kind of standard things on top. So we definitely see that, but making that available to people, as a programming experience, gets us back to one of the original discussions we had about an hour ago. Is with P4 programmability, one of the big debates in that community is who does the programming. So is it a vendor? Can you put extra capabilities or extra protocols in the product by programming it internally in P4, or is it a kind of operator adds features for their network, or does the end user get to program the protocols themselves? So that would be the ultimate kind of application experience if you could get at it. And it kind of neatly ties together various threads of our discussion, because then potentially there's a huge security threat. If people are allowed to, end users can put their own protocols into the network. A long time ago, the active networking trend in late 1990s was a dangerous idea. Instead of packets, you had capsules going through the network, which were executable programs. They came to a switch, and it would get executed, and telcos threw their hands up in horror at that concept, from a security concept. So this is a kind of long answer, but I think one of the things with programmability in the SmartNIC is allowing people to do custom protocols. But, we have to be very careful about who are these people and how do we keep it secure.
Thanks, Gordon. I mean, shameless plug, my research group is working on remote virtual memory access, which is a topic that we brought up at IPDPS in past years. And using SmartNICs in that context is, yes, it's a new protocol. It's an abstraction of RDMA that lets us do some interesting things like fault tolerance over RDMA, but implementing those things sort of on top of things in a SmartNIC. Right, so SmartNICs let us explore what we'd like to be able to do in hardware easier than we ever have in the past, because we can do things in more real terms than just simulation to prove out some of these concepts. So yes, some work's being done there, but I think it's a little early to have a really great body of knowledge there. But keep an eye on what's going on in the next year or two, and I think we should have some interesting material out for you to read on. Sort of stretching the boundaries of what we think future network protocols could be. So from a research perspective, I'll pitch that for the SC community. They're very interesting for doing that sort of research as well. You might not get the end numbers that you get from hardware, but you can at least pitch functionality for things like fault tolerance and other things like that would be features. Anybody else have any comments on that? Otherwise, I'll go on to what will probably be our last question before we close. All right, so closing with last question, Lauren's asking what tools will be available either now or in the future for SmartNIC programmers? How do you debug and optimize this stuff? And will such environments be integrated with their CPU and GPU tools? In other words, can you program them in the regular tool chain and from a CPU host side? Steve, I'm certain you will have comments on that. What does the SmartNIC programming interface look like? There are a lot of different devices out there that provide a lot of different interfaces. So comments from the panel.
So I can say with the sort of support that we have today, you have the same tool chain that you have on your host works on the SmartNIC, because you're basically running Linux. You are running a version of Linux using your standard compilers and the like. In terms of integrating into an end-to-end tool chain, that's certainly something that has to happen. It has to happen over time if this environment's it will be used.
So we have a collection of asterisk PUs, whether it's an I or a D or any letters soon to be changed. All of the ones, so the ones we have from Broadcom, Intel, Mellanox, and Marvell, sorry, NVIDIA, I get confused easily. All of them I can program basically just by, and this is the rub, I can program them by either by a cross compilation, or I can actually log onto the device, build everything I need there because it runs Linux, and I can leave it resident on the machine, on the SmartNIC itself. We have looked and continue to look at, to Gordon's comment, we have actually looked at P4 as an option, as one of the chains inside of OpenSnappy, because of the community that does exist in the P4 community from a programming point of view. Lanel actually does do some of their own P4 programming, and it is on some FPGAs that we are normally using for storage. So we have a fairly large storage undertaking where we're using quote unquote SmartNICs for that. And that's a project run by Brad Settlemeyer and Gary Grider. And they've been using that now for about a year. And we have our own, we've worked with some vendors to customize some FPGA code that allows us to do the things we like. I eventually don't want to leave this in the hands of an apps programmer, because that just can be fraught with excitement, the kind I'm not necessarily fond of. So one of our goals is to make it so that if they want to go in and hurt themselves, we're not going to stop them from, bruising themselves. But by and large, we want it such that it is integrated into the tool chain. And even though I'm a little more interested in OpenSHMEM than I am MPI, I do know that the DOE has, for some reason, funded MPI for a while, and it has to be something that I pay attention to. So we are already, in fact, the first release of OpenHPCA is MPI based, not OpenSHMEM based. So I do expect to see all of these things integrated into, like we've integrated into UCX. You run UCX and you have the capability of doing a lot of the underpinnings of writing code to run on SmartNICs. So you're correct, and I do not think this will happen in a year. But I think we will have tools in less than 6 months that show you that you can actually do this and not bleed to death.
Yeah, the putting middleware and tool development in the hand of computer scientists instead of physicists is a good idea, right, Steve?
Oh, yes, it's life sustainability.
It's not that we don't love our physicist colleagues, but we can take that one for the team to get that done for you. So, okay, we're almost at the end of the panel. So I'd like to ask if any member panels had any final comments, final thoughts that you didn't get to say while we were going through questions that you think that's important that you want to address the audience. This is your last chance.
I saw some questions around benchmarks, and I was going to say there's the OpenHPCA benchmark that Steve also kind of put the link on GitHub to. I would, for those, because I saw some questions around benchmarks, for those who are interested in some of those, please take a look. It's on GitHub, literally UCX/OpenHPCA. And yeah, that's one place to start.
And every, like to Roxana's point, everything that's going on within OpenHPCA or OpenSnappy, just like OpenSHMEM, the reason I chose the front the front word, open, it is vendor agnostic. None of the source code is restricted. None of it's export controlled. And what I would ask from the audience is I don't care what you join. If you have questions, you have comments, I think everybody logged in knows our email addresses, and you should feel, or if not, send them to Ryan and send us the questions to start a dialogue, because we will do what we're going to do without any external influence. So if you have things that you would like, make sure that your requests are known, and we'll send all of those questions to Gordon.
Perfect, thanks. Yeah, if anybody wants to get in contact with me, it's just ryan.grant@queensu.ca. queensu.ca. And I can get you in contact with any of the panelists. All right, with that, we are perfectly at time. So I'd like to extend a big thank you to all of our panelists. We appreciate your time and efforts to be here. Really appreciate it. I thought this was a great discussion, and we got great attendance throughout the session. I think we topped out at about 100 attendees. People have been coming and going, so I'm certain there's more people, physical people than that have been coming and going virtually into the rooms. So thanks everybody for the discussion, and thank you for everybody for participating and offering your questions. Apologies that we didn't get to all of them, but everybody's obviously very interested in the topic. We appreciate you attending this panel this year. Thank you very much.